Question 1. When evaluating the potential impact of an application update on IBM SmartCloud Application Performance Management v7, which approach best ensures the continued accuracy and effectiveness of performance monitoring? Option A. Assuming that if the application functions correctly from a user perspective, the IBM v7 monitoring will automatically adapt without any specific impact assessment. Option B. Relying on end-user feedback after the application update is deployed to identify any perceived performance issues that might indicate APM monitoring gaps. Option C. Conducting a thorough review of the application updates technical specifications to identify potential conflicts with APM agents and data collection mechanisms, followed by targeted testing in a staging environment to validate APM data integrity and alert functionality. Option D. Proceeding with the application update in the production environment and addressing any APM-related issues that arise as separate, post-deployment incidents. Correct answer is C. Conducting a thorough review of the application updates technical specifications to identify potential conflicts with APM agents and data collection mechanisms, followed by targeted testing in a staging environment to validate APM data integrity and alert functionality. Explanation. This scenario is professionally challenging because the impact assessment for IBM SmartCloud Application Performance Management (IBM) v7 requires a nuanced understanding of how changes to application code or infrastructure can affect performance monitoring capabilities. The challenge lies in anticipating potential disruptions to data collection, analysis, and reporting without introducing new performance bottlenecks or compromising the integrity of the monitoring data itself. Careful judgment is required to balance the benefits of application updates with the need for continuous and accurate performance insights. The correct approach represents best professional practice because it prioritizes a proactive and systematic evaluation of potential impacts on APM functionality. This involves thoroughly understanding the proposed changes, identifying critical APM components that might be affected, e.g., agents, data collectors, dashboards, and defining clear testing procedures to validate APM's ability to monitor the modified application. This aligns with the general principles of IT service management and change control, which emphasize minimizing risk and ensuring service continuity. While specific regulations for APM v7 are not detailed in the prompt, the underlying professional responsibility is to maintain the integrity and effectiveness of the monitoring solution, which is a critical component for operational stability and compliance with any performance-related service-level agreements. An incorrect approach that focuses solely on the application's functional changes without considering the APM integration would be professionally unacceptable. This failure stems from a lack of holistic system thinking and could lead to a situation where the application functions correctly, but its performance is unmonitored or inaccurately reported. This could result in missed performance degradations, delayed incident response, and ultimately, a breach of service-level agreements, which could have contractual and reputational consequences. Another incorrect approach that involves deploying changes without any pre-deployment testing of APM integration is a significant regulatory and ethical failure. This demonstrates negligence and a disregard for the operational impact of changes. It directly jeopardizes the ability to maintain a stable and performant application environment, potentially leading to service outages that could violate industry standards or contractual obligations related to application availability and performance. A third incorrect approach that relies on anecdotal feedback from users to assess APM impact is also professionally unsound. While user feedback is valuable, it is subjective and often reactive. It does not provide the objective, data-driven insights necessary for a comprehensive impact assessment of a performance monitoring tool. This approach fails to proactively identify and address technical issues that could compromise the APM system's effectiveness, leading to a lack of reliable performance data and potential compliance issues. The professional decision-making process for similar situations should involve a structured change management framework. This includes 1. Change identification, clearly defining the proposed change and its objectives. 2. Impact analysis, systematically assessing the potential effects on all relevant IT components, including APM. 3. Risk assessment, evaluating the likelihood and severity of identified risks. 4. Planning, Developing a detailed plan for implementing the change, including testing, rollback procedures, and communication. 5. Testing. Conducting thorough testing in a pre-production environment to validate both application functionality and APM monitoring. 6. Deployment. Implementing the change according to the plan. 7. Review. Post-implementation review to confirm successful deployment and ongoing performance. Question 2. Market research demonstrates that organizations often struggle to effectively diagnose performance degradation in their applications. When using IBM SmartCloud Application Performance Management V7. 7. Which of the following approaches is most likely to lead to the efficient identification and resolution of performance bottlenecks? Option A. Focusing exclusively on network latency metrics without considering application-specific performance indicators. Option B. Relying solely on user-reported issues and support tickets to initiate performance investigations. Option C. Analyzing application transaction traces to identify specific slowdowns and correlating these with resource utilization metrics. Option D. Collecting all available raw performance data logs from all monitored components and performing a comprehensive manual review. The correct answer is C. Analyzing application transaction traces to identify specific slowdowns and correlating these with resource utilization metrics. Explanation. This scenario presents a professional challenge due to the inherent complexity of performance monitoring and the need to balance detailed data analysis with actionable insights. The challenge lies in selecting the most effective method to identify and resolve performance bottlenecks within IBM SmartCloud Application Performance Management (APM) V7. 7. Ensuring that the chosen approach aligns with best practices for application health and user experience, while also considering the efficient use of resources. Careful judgment is required to avoid overanalysis or underanalysis, both of which can lead to suboptimal outcomes. The correct approach represents best professional practice because it directly addresses the core functionality of APM by focusing on identifying deviations from expected performance baselines. This method leverages the diagnostic capabilities of APM to pinpoint specific areas of concern, such as high response times or resource utilization, which are critical for effective troubleshooting. By correlating these metrics with application behavior, professionals can quickly understand the root cause of performance issues. This aligns with the fundamental purpose of APM, which is to provide visibility into application performance and enable proactive problem resolution, ultimately ensuring service-level agreements, SLAs, are met and user satisfaction is maintained. An incorrect approach that focuses solely on collecting vast amounts of raw data without a clear analytical framework is professionally unacceptable. This fails to leverage the intelligence of the APM tool, leading to information overload and an inability to derive meaningful insights. It represents a failure to apply the tool effectively and can result in wasted resources and delayed problem resolution. Another incorrect approach that relies on anecdotal evidence or user complaints without validating them with APM data is also professionally unsound. This bypasses the objective, data-driven nature of APM, potentially leading to misdiagnosis and ineffective remediation efforts. It demonstrates a lack of reliance on the established monitoring and diagnostic capabilities of the system. The professional decision-making process for similar situations should involve a systematic approach. 1. Understand the business impact of performance issues. 2. Define clear objectives for performance monitoring and analysis. 3. Leverage the specific features and capabilities of the APM tool to gather relevant data. 4. Establish performance baselines and thresholds. 5. Correlate observed performance metrics with application behavior and user experience. 6. Prioritize issues based on their impact and urgency. 7. Implement targeted remediation strategies based on data-driven insights. 8. Continuously monitor and validate the effectiveness of remediation efforts. Question 3. The performance metrics show a significant increase in transaction response times for the order processing service, accompanied by a spike in CPU utilization on the database server hosting the order data. However, user reports indicate that only a subset of users are experiencing delays, and these delays are intermittent. What is the most appropriate initial step to diagnose this discrepancy? Option A. Focus solely on the user reports to identify patterns in their reported delays, ignoring the APM metrics for now. Option B. Analyze transaction traces within IBM SmartCloud application performance management to identify specific slow transactions and their associated database queries. Option C. Restart the order processing service to clear any potential temporary glitches. Option D. Immediately scale up the database server's resources to alleviate the perceived load. The correct answer is B. Analyze transaction traces within IBM SmartCloud application performance management to identify specific slow transactions and their associated database queries. Explanation: scenario analysis. This scenario presents a common challenge in application performance management, where observed metrics do not immediately align with expected behavior or user reports. The professional challenge lies in accurately diagnosing the root cause without making premature assumptions, which could lead to misallocation of resources, ineffective remediation, and potential service degradation. The need for careful judgment is paramount to ensure that decisions are data-driven and aligned with the operational objectives of the application and the business. Correct approach analysis. The correct approach involves a systematic investigation that begins with correlating the observed performance metrics with known application behavior and recent changes. This aligns with best professional practice by prioritizing a thorough understanding of the system state before implementing solutions. In the context of IBM SmartCloud Application Performance Management V7 fundamentals, this means leveraging the diagnostic tools and data provided by the platform to identify anomalies, trace transaction flows, and pinpoint resource bottlenecks. This methodical approach ensures that remediation efforts are targeted and effective, minimizing disruption and maximizing the likelihood of restoring optimal performance. It also implicitly supports the principle of responsible IT operations, ensuring that changes are made with a clear understanding of their impact. Incorrect approaches analysis. One incorrect approach is to immediately assume a specific component failure based on a single metric. This bypasses the crucial step of comprehensive analysis, potentially leading to wasted effort on the wrong problem. Ethically, this could be seen as negligent if it delays the resolution of the actual issue, impacting users and business operations. Another incorrect approach is to disregard the performance metrics entirely and rely solely on anecdotal user feedback. This ignores the objective data available through APM, which is designed to provide precise insights. Such an approach lacks professional rigor and can lead to subjective and potentially inaccurate conclusions, failing to meet the standards of effective IT service management. A third incorrect approach might be to implement a broad, system-wide change without understanding the specific cause. This is a high-risk strategy that could introduce new problems or exacerbate existing ones, demonstrating a lack of due diligence and potentially violating operational guidelines that mandate controlled change management. Professional reasoning. Professionals should employ a structured decision-making framework that prioritizes data analysis and systematic problem-solving. This framework typically involves 1. Observation and data collection, utilizing APM tools to gather comprehensive performance data. 2. Hypothesis generation, forming educated guesses about potential causes based on the data. 3. Testing and validation, systematically testing hypotheses by examining related metrics, logs, and system configurations. 4. Root cause identification, pinpointing the definitive cause of the performance issue. 5. Solution implementation, developing and applying targeted solutions. 6. Verification, confirming that the solution has resolved the issue and prevented recurrence. This iterative process ensures that decisions are informed, efficient, and aligned with best practices for application performance management. Question 4. Benchmark analysis indicates that a new deployment of IBM SmartCloud Application Performance Management V7 requires a strategic approach to monitoring probe deployment to optimize resource utilization and ensure effective performance insights. Considering the need for both comprehensive visibility and efficient resource management, which deployment strategy best aligns with professional best practices for application performance management? Option A. Immediately enable all available monitoring probes across all applications to ensure maximum data collection from the outset, regardless of resource implications. Option B. Disable monitoring probes for applications categorized as non-critical to conserve system resources and focus only on high-priority applications. Option C. Rely solely on reactive monitoring, enabling probes only when performance degradation is reported by users or other systems. Option D. Implement monitoring probes incrementally, starting with critical application components and gradually expanding coverage based on initial findings and resource availability, while establishing baseline performance metrics. The correct answer is D. Implement monitoring probes incrementally, starting with critical application components and gradually expanding coverage based on initial findings and resource availability, while establishing baseline performance metrics. Explanation: this scenario presents a professional challenge because it requires balancing the need for continuous application performance monitoring with the potential for resource constraints and the impact on application stability. The core of the challenge lies in selecting the most effective and efficient monitoring strategy without compromising the integrity or performance of the applications being managed. Careful judgment is required to align monitoring objectives with available resources and to ensure compliance with any relevant service level agreements, SLAs, or operational policies. The correct approach represents best professional practice because it prioritizes a phased and targeted implementation of monitoring capabilities. This strategy allows for the validation of critical performance metrics and the establishment of baseline performance before expanding coverage. It aligns with the principle of least privilege and efficient resource utilization, ensuring that monitoring efforts are focused on areas with the highest potential impact on application performance and user experience. This methodical approach also facilitates easier troubleshooting and reduces the risk of introducing performance degradation due to overly aggressive or poorly configured monitoring. From a regulatory and ethical standpoint, this approach demonstrates due diligence in managing application performance, which can be indirectly related to data integrity and availability requirements if the applications handle sensitive information or critical business processes. An incorrect approach that involves immediately enabling all available monitoring probes across all applications without prior assessment is professionally unacceptable. This is because it can lead to significant overhead, potentially impacting application performance and consuming excessive system resources. Such an indiscriminate approach could violate operational efficiency guidelines and potentially lead to false positives or an overwhelming volume of data, hindering effective analysis and response. It also fails to demonstrate a strategic understanding of performance management, potentially leading to wasted investment in monitoring tools and resources. Another incorrect approach, which is to disable monitoring for non-critical applications to conserve resources, is also professionally unsound. While resource conservation is important, completely disabling monitoring for any application, even if deemed non-critical, carries risks. It can mask underlying performance issues that might eventually impact critical functions or user experience, leading to unexpected outages or degraded service. This approach lacks foresight and a comprehensive understanding of interconnected application dependencies. It may also contravene internal policies or SLAs that mandate a certain level of visibility across all managed applications. A third incorrect approach, focusing solely on reactive monitoring after performance degradation is reported, is also professionally deficient. This reactive stance fails to leverage the proactive capabilities of IBM SmartCloud application performance management. Effective performance management relies on establishing baselines, detecting anomalies early, and preventing issues before they impact users. A purely reactive approach can lead to longer downtime, increased recovery costs, and damage to user trust and business reputation. It neglects the fundamental purpose of performance monitoring, which is to ensure optimal and stable application operation. The professional reasoning process for making such decisions should involve a thorough understanding of the application landscape, business criticality of each application, available infrastructure resources, and the specific objectives of performance monitoring. This includes defining clear performance indicators, KPI, establishing baselines, and prioritizing monitoring efforts based on risk and impact. A phased implementation, continuous evaluation, and adaptation of monitoring strategies are key to effective application performance management. Question 5. The monitoring system demonstrates an unexpected capture of what appears to be personally identifiable information, PI, within its performance logs, which were not explicitly configured to collect such data. The IT administrator responsible for the system is aware of this anomaly. What is the most appropriate immediate course of action? Option A. Immediately halt the monitoring of the affected application and escalate the issue to the security and compliance teams for a thorough investigation and remediation plan. Option B. Manually delete the captured PII from the logs to prevent any potential future access or misuse. Option C. Continue monitoring as usual, assuming the captured data is anonymized and poses no significant risk, and address it during the next scheduled system review. Option D. Silently adjust the monitoring configuration to exclude the PII without informing any other department, to avoid unnecessary alarm. The correct answer is A. Immediately halt the monitoring of the affected application and escalate the issue to the security and compliance teams for a thorough investigation and remediation plan. Explanation. This scenario presents an ethical dilemma common in IT operations, particularly concerning data privacy and system integrity. The challenge lies in balancing the need for comprehensive performance monitoring with the potential for unauthorized access to sensitive customer data that might be incidentally captured by the monitoring tools. The exam's jurisdiction, see 2010-515 IBM SmartCloud Application Performance Management V7. 7 Fundamentals, implies a focus on IBM-specific product capabilities and best practices within a general IT governance framework, likely aligned with common industry standards for data protection and operational transparency. The correct approach involves a proactive and transparent method of addressing the potential data exposure by immediately escalating the issue to the appropriate internal stakeholders, such as the security and compliance teams, and initiating a review of the monitoring configuration. The IT professional demonstrates a commitment to ethical data handling and regulatory compliance. This approach prioritizes minimizing risk and ensuring that data capture aligns with established policies and legal requirements. It reflects best professional practice by adhering to principles of due diligence, accountability, and the protection of sensitive information. An incorrect approach would be to ignore the potential issue, assuming it's a minor oversight or that the data is not truly sensitive. Failure to investigate and address a potential breach of data privacy would violate ethical obligations and could lead to significant regulatory penalties if customer data were indeed compromised. Another incorrect approach would be to unilaterally alter the monitoring configuration without proper authorization or consultation. This could disrupt critical performance monitoring, leading to service degradation or outages, and bypass established change management procedures, which themselves are often dictated by regulatory compliance requirements. Furthermore, it could be seen as an attempt to conceal the issue rather than resolve it transparently. Professionals facing such situations should employ a structured decision-making process. This involves 1. Identifying the potential risk and its scope. 2. Consulting relevant internal policies, procedures, and regulatory guidelines. 3. Escalating the issue to the appropriate channels for expert review and decision-making. 4. Documenting all actions taken and decisions made. 5. Implementing corrective actions in a controlled and authorized manner. This systematic approach ensures that decisions are informed, ethical, and compliant with all applicable frameworks. Question 6. Operational review demonstrates that the initial deployment of IBM SmartCloud Application Performance Management V7 has led to an observed increase in application response times and higher resource utilization on monitored servers. The implementation team needs to adjust the monitoring configuration to mitigate these impacts while still ensuring sufficient visibility into application performance. Which of the following approaches best addresses this implementation challenge? Option A. Increase the server resources allocated to the monitoring infrastructure and agents to accommodate the current level of data collection, assuming the current configuration provides the necessary visibility. Option B. Enable all available monitoring metrics at their most granular collection intervals to ensure no performance aspect is overlooked, and then address any performance degradation through further server resource allocation. Option C. Gradually reduce the data collection intervals for less critical components and selectively disable monitoring for specific metrics that are not immediately essential for troubleshooting, based on initial performance analysis and resource consumption trends. Option D. Immediately disable all non-essential monitoring agents and reduce data collection intervals across the board to minimize overhead, with a plan to re-enable them only if specific performance issues arise. The correct answer is C. Gradually reduce the data collection intervals for less critical components and selectively disable monitoring for specific metrics that are not immediately essential for troubleshooting, based on initial performance analysis and resource consumption trends. Explanation: this scenario presents a common implementation challenge in performance management, balancing the need for comprehensive data collection with the potential for performance degradation and resource overutilization. The core difficulty lies in identifying the optimal configuration of monitoring agents and their associated data collection intervals without negatively impacting the application's responsiveness or incurring excessive infrastructure costs. This requires a nuanced understanding of the application's behavior under various load conditions and a strategic approach to data granularity. The correct approach represents best professional practice because it prioritizes a phased, data-driven methodology. By starting with a baseline configuration and incrementally adjusting based on observed performance metrics and resource utilization, the implementation team avoids making broad, potentially detrimental changes. This iterative process, coupled with careful consideration of the application's criticality and user impact, aligns with the principles of responsible IT service management and ensures that performance monitoring enhances, rather than hinders, application availability and performance. This aligns with the general principles of IT governance and operational excellence expected in any professional IT environment, ensuring that tools are used effectively and efficiently. An incorrect approach that involves immediately enabling all available monitoring metrics at their most granular settings would be professionally unacceptable. This would likely lead to significant overhead, potentially impacting application performance and increasing infrastructure costs without a clear understanding of which metrics are truly valuable. This demonstrates a lack of foresight and a failure to apply a risk-based approach to implementation, potentially violating implicit service-level agreements regarding application responsiveness. Another incorrect approach, such as disabling monitoring for non-critical components entirely without proper analysis, could lead to blind spots in performance visibility. This might result in undetected issues in those components, which could eventually cascade and affect critical services. This represents a failure to maintain adequate oversight and a potential breach of due diligence in ensuring the overall health of the application ecosystem. The professional decision-making process for similar situations should involve a thorough understanding of the application's architecture and business criticality. It requires defining clear objectives for performance monitoring, establishing baseline performance metrics, and then implementing monitoring in a phased manner. Continuous evaluation of the impact of monitoring on application performance and resource consumption is crucial. Professionals should leverage their knowledge of the specific IBM SmartCloud Application Performance Management V7 capabilities to select appropriate agents and configurations, always prioritizing a balance between comprehensive visibility and operational efficiency. Question 7. The performance metrics show a significant increase in transaction response times for a critical business application monitored by IBM SmartCloud Application Performance Management V7. While end-user reports indicate slow loading pages, the network latency metrics within APM appear to be within normal operating ranges. Which of the following analytical approaches would best identify the root cause of this performance degradation? Option A. Focus on correlating the increased transaction response times with high CPU and memory utilization on the application servers, and examine detailed transaction traces within APM to identify specific code segments or database queries that are consuming excessive resources. Option B. Prioritize investigating potential issues with the external network infrastructure connecting the users to the application servers, as end-user reports often point to network problems. Option C. Immediately conclude that the issue is with the application's front-end code and recommend a complete rewrite of the user interface to improve loading times. Option D. Analyze only the overall error rates reported by APM, assuming that an increase in errors directly correlates with the observed slowdown, and focus remediation efforts on fixing the most frequent error types. The correct answer is A. Focus on correlating the increased transaction response times with high CPU and memory utilization on the application servers, and examine detailed transaction traces within APM to identify specific code segments or database queries that are consuming excessive resources. Explanation: This scenario presents a common challenge in application performance management, interpreting complex data to identify the root cause of performance degradation. The professional challenge lies in distinguishing between symptoms and underlying issues, especially when multiple factors could be contributing. A hasty conclusion based on superficial data can lead to misallocation of resources, prolonged downtime, and potential financial or reputational damage for the organization. Careful judgment is required to correlate different data points and understand their interdependencies within the IBM SmartCloud Application Performance Management (APM) v7 environment. The correct approach involves a systematic analysis of the performance metrics, correlating data from various APM components to pinpoint the actual bottleneck. This aligns with best professional practices by ensuring that troubleshooting efforts are directed at the true source of the problem, minimizing downtime and optimizing resource utilization. In the context of IBM SmartCloud APM v7, this means leveraging its capabilities to drill down into specific transaction traces, resource utilization, CPU, memory, network, and application logs to identify the component or code path causing the slowdown. This methodical approach is implicitly supported by the operational guidelines and best practices associated with managing enterprise-level applications, emphasizing efficiency and effectiveness in problem resolution. Incorrect approaches fail to meet professional standards by either oversimplifying the problem or focusing on irrelevant data, attributing the performance issue solely to network latency without examining application-level metrics is a failure to conduct a comprehensive analysis. This could lead to unnecessary network infrastructure investments, while the actual problem lies within the application code or database queries. Similarly, focusing only on end-user experience metrics without investigating the server-side performance is incomplete. This neglects the critical server-side components that directly impact user experience. A failure to correlate data across different APM monitoring domains, e.g., application, server, database, represents a significant gap in professional due diligence. The professional decision-making process for similar situations should involve 1. Clearly defining the observed problem, e.g., increased response times, high error rates. 2. Utilizing the IBM SmartCloud APM v7 console to gather all relevant metrics across different monitoring domains. 3. Systematically correlating data, looking for patterns and anomalies that appear concurrently with the performance degradation. 4. Formulating hypotheses about potential root causes and testing them by drilling down into specific traces, logs, and resource utilization data. 5. Validating the identified root cause before implementing any remediation steps. Question 8. Cost-benefit analysis shows that implementing comprehensive monitoring across all components of a critical financial transaction application using IBM SmartCloud Application Performance Management v7 would incur significant upfront and ongoing costs. However, a partial implementation, focusing only on the user interface and database layers, would substantially reduce these costs. Considering the regulatory environment for financial services, which mandates high availability and data integrity for transaction processing, what is the most professionally responsible approach to configuring APM v7? Option A. Focus monitoring efforts on the most frequently used transaction paths, accepting a reduced level of insight into less common but potentially critical transaction flows to balance cost and coverage. Option B. Deploy a basic monitoring solution that flags only critical system errors, without detailed performance metrics, to achieve maximum cost savings while still addressing the most severe potential issues. Option C. Implement monitoring only for the user interface and database layers to minimize costs, assuming that issues in other layers are less likely to impact end-user experience or data integrity directly. Option D. Prioritize monitoring of all layers of the financial transaction application, including middleware and application server components, to ensure full visibility and compliance with stringent regulatory requirements for availability and data integrity, even if it incurs higher costs. Correct answer is D. Prioritize monitoring of all layers of the financial transaction application, including middleware and application server components, to ensure full visibility and compliance with stringent regulatory requirements for availability and data integrity, even if it incurs higher costs. Explanation. This scenario presents a common challenge in IT performance management. balancing the cost of comprehensive monitoring with the perceived benefits. The professional challenge lies in making an informed decision that aligns with regulatory expectations for application availability and performance, without incurring unnecessary expenditure. IBM SmartCloud Application Performance Management (APM) v7 as a tool is designed to provide insights that can prevent or mitigate performance issues, which directly impact service level agreements, SLAs, and potentially regulatory compliance depending on the industry. The correct approach emphasizes a proactive, risk-based strategy. By focusing on critical business services and their dependencies, an organization can ensure that the most impactful areas are monitored effectively. This aligns with the principle of proportionality in regulatory compliance, where resources are allocated to address the highest risks. In the context of application performance, this means ensuring that core functionalities, which if degraded or unavailable, would cause significant business disruption or regulatory noncompliance, are under vigilant observation. This approach demonstrates due diligence and a commitment to maintaining service integrity, which is often an implicit or explicit requirement in many regulatory frameworks governing data availability and service continuity. An incorrect approach that prioritizes cost savings by under-monitoring critical components is professionally unacceptable. This failure stems from a disregard for potential business impact and regulatory obligations. For instance, if an application handles sensitive customer data or is part of a regulated financial transaction, a lack of adequate performance monitoring could lead to data breaches, service outages, or noncompliance with data protection laws or financial regulations. Such an oversight could result in significant financial penalties, reputational damage, and legal repercussions. Another incorrect approach might involve implementing monitoring without a clear understanding of what constitutes performance or availability in a regulatory context, leading to the collection of irrelevant data or the failure to detect critical issues. This demonstrates a lack of strategic planning and a superficial engagement with compliance requirements. The professional decision-making process should involve a thorough understanding of the business's critical functions, the regulatory landscape applicable to those functions, and the capabilities of APM tools like IBM SmartCloud APM v7. This includes identifying key performance indicators, KPI, that are relevant to both business objectives and regulatory mandates. A risk assessment should then be conducted to determine the potential impact of performance degradation on these critical functions and regulatory compliance. Based on this assessment, a monitoring strategy should be developed that prioritizes resources for the most critical areas, ensuring that the benefits of monitoring, e.g., early detection of issues, faster resolution, compliance assurance, outweigh the costs. Regular review and adjustment of the monitoring strategy based on evolving business needs and regulatory changes are also crucial. Question 9. The risk matrix shows a critical performance anomaly detected by IBM SmartCloud Application Performance Management v7, impacting a key financial transaction processing application. The anomaly is characterized by intermittent, significant latency spikes that are not currently impacting end-user experience, but are flagged as high risk due to their potential to escalate. What is the most appropriate immediate course of action to ensure both system stability and data integrity? Option A. Initiate a controlled diagnostic session using IBM SmartCloud APM v7 tools to gather detailed performance metrics and trace the transaction flow during an anomaly event, while simultaneously documenting the observed symptoms and risk assessment. Option B. Contact the application vendor for immediate support and guidance, bypassing internal diagnostic efforts. Option C. Monitor the anomaly passively, assuming it is a temporary glitch that will resolve itself without intervention, and only take action if end-user impact becomes apparent. Option D. Immediately restart the affected application services to clear any potential transient issues and restore normal performance levels. The correct answer is A. Initiate a controlled diagnostic session using IBM SmartCloud APM v7 tools to gather detailed performance metrics and trace the transaction flow during an anomaly event, while simultaneously documenting the observed symptoms and risk assessment. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for performance data with the long-term implications of data integrity and compliance. The core of the challenge lies in determining the most appropriate method for addressing a critical performance anomaly detected by IBM SmartCloud Application Performance Management APM V7. 7. Given the potential for data corruption or misinterpretation, the chosen approach must not only resolve the immediate issue, but also adhere to established best practices for incident management and data handling within the context of the specified regulatory framework. The correct approach represents best professional practice because it prioritizes data integrity and a systematic, documented resolution process. By initiating a diagnostic session and carefully collecting data, the IT professional ensures that the root cause is accurately identified without introducing further anomalies or compromising existing records. This aligns with the principles of responsible IT operations, emphasizing thorough investigation and evidence-based decision-making. Adherence to established incident management procedures, which typically involve controlled diagnostic steps and validation, is crucial for maintaining system stability and auditability. An incorrect approach that involves immediately restarting services without proper diagnosis poses significant regulatory and ethical failures. Restarting services without understanding the root cause can mask the underlying problem, leading to recurring incidents and potential data loss or corruption. This violates the principle of due diligence in IT operations and could be seen as a failure to adequately manage and protect critical application performance data, which may have compliance implications depending on the industry and specific regulations governing data retention and integrity. Another incorrect approach, such as selectively ignoring the anomaly if it appears to resolve itself, is also professionally unacceptable. This demonstrates a lack of proactive problem-solving and a disregard for potential systemic issues. It fails to meet the professional obligation to investigate and resolve performance deviations, potentially leaving the system vulnerable to future, more severe failures. This can also lead to a breach of service-level agreements, SLAs, and a failure to meet operational standards, which can have contractual and reputational consequences. Third incorrect approach, such as immediately escalating to a vendor without attempting initial internal diagnostics, can be inefficient and costly. While vendor involvement is sometimes necessary, bypassing fundamental troubleshooting steps can lead to unnecessary delays and expenses. It also fails to demonstrate the internal team's capability to manage and resolve common performance issues, potentially impacting internal confidence and external perceptions of competence. The professional decision-making process for similar situations should involve a structured incident response framework. This typically includes 1. Incident detection and logging, recognizing and recording the anomaly. 2. Initial triage and assessment, understanding the impact and severity. 3. Diagnosis and root cause analysis, employing controlled diagnostic tools and techniques like those offered by IBM SmartCloud APM V7. 7. To identify the underlying issue. 4. Resolution and recovery, implementing a solution based on the diagnosed root cause. 5. Verification and closure, confirming the issue is resolved and documenting the entire process. This systematic approach ensures that all actions are deliberate, documented, and aimed at restoring service while maintaining data integrity and compliance. Question 10. The assessment process reveals that IBM SmartCloud Application Performance Management V7 is deployed to monitor critical business applications. During a review of the collected performance metrics, it is noted that certain transaction logs contain user session data that could potentially include sensitive personal information. To ensure regulatory compliance and protect user privacy, what is the most appropriate action to take regarding the data collection and retention policies within APM? Option A. Configure APM data collection to mask or exclude sensitive data fields from transaction logs and implement a data retention policy that aligns with regulatory requirements for anonymized or aggregated data. Option B. Assume that the default APM configuration adequately protects sensitive data and continue with the current data collection and retention practices. Option C. Rely on post-collection data sanitization processes to remove sensitive information from transaction logs before they are archived. Option D. Increase the volume of data collected by APM to capture a more comprehensive view of application performance, without specific regard for the nature of the data within transaction logs. The correct answer is A. Configure APM data collection to mask or exclude sensitive data fields from transaction logs and implement a data retention policy that aligns with regulatory requirements for anonymized or aggregated data. Explanation. The assessment process reveals a common challenge in IT operations, balancing the need for comprehensive performance monitoring with the strict requirements of data privacy regulations. In this scenario, the challenge lies in ensuring that the data collected by IBM SmartCloud Application Performance Management, APM, V7 for performance analysis does not inadvertently capture or expose sensitive personal information, which could lead to regulatory violations and reputational damage. The professional challenge is to implement effective monitoring without compromising compliance. The correct approach involves a proactive and layered strategy for data masking and anonymization. This aligns with the principles of data minimization and privacy by design, which are fundamental to many data protection regulations. By configuring APM to mask or exclude sensitive data fields at the source or during collection, organizations demonstrate a commitment to protecting user privacy while still gathering the necessary performance metrics. This approach is best professional practice because it directly addresses regulatory mandates for data protection and minimizes the risk of breaches or unauthorized access to sensitive information. It also fosters trust with users and stakeholders. An incorrect approach would be to assume that APM's default configurations are sufficient for regulatory compliance. This overlooks the responsibility of the organization to actively manage and secure the data it collects. Failing to implement specific data masking or anonymization techniques for sensitive fields, such as personally identifiable information, PI, or financial details, constitutes a regulatory failure. It exposes the organization to potential fines and legal repercussions under data protection laws. Another incorrect approach is to rely solely on post-collection data sanitization. While this can be a secondary measure, it is less effective and riskier than preventing the collection of sensitive data in the first place. If sensitive data is collected, even for a short period, it increases the attack surface and the potential for accidental exposure or misuse, leading to compliance breaches. The professional decision-making process for similar situations should involve a thorough understanding of the data being monitored, the specific regulatory requirements applicable to that data, and the capabilities of the monitoring tools. This includes conducting a data privacy impact assessment, consulting with legal and compliance teams, and configuring monitoring tools with privacy as a primary consideration. Professionals should always prioritize preventative measures and adopt a privacy by design philosophy when implementing IT solutions. Question 11. The performance metrics show a significant increase in transaction response times for a critical e-commerce application, coupled with a spike in network latency between the application servers and the database. The application logs, however, indicate no new errors or unusual activity within the application code itself. What is the most appropriate initial course of action to diagnose the root cause of this performance degradation? Option A. Focus on investigating and correlating network infrastructure health, database server performance, and resource utilization on both application and database servers with the observed transaction response times. Option B. Assume the performance metrics are inaccurate due to a potential monitoring agent issue and proceed with a full system restart to resolve any transient problems. Option C. Prioritize optimizing database queries, as database performance is often the primary driver of application response times, regardless of other observed metrics. Option D. Immediately initiate a code review and profiling of the application to identify potential performance bottlenecks within the application logic. The correct answer is D. Immediately initiate a code review and profiling of the application to identify potential performance bottlenecks within the application logic. Explanation. This scenario presents a common challenge in performance monitoring, distinguishing between genuine application issues and environmental factors that can skew metrics. The professional challenge lies in accurately diagnosing the root cause of performance degradation to implement effective remediation, avoiding wasted resources on misdiagnosed problems. The regulatory framework for IBM SmartCloud Application Performance Management V7 fundamentals, while not explicitly detailing specific external regulations, implies adherence to best practices for system reliability and data integrity, which are foundational to any IT governance. The correct approach involves a systematic investigation that correlates application performance data with infrastructure and network health. This aligns with best professional practice by ensuring that remediation efforts are targeted and efficient. By examining logs, resource utilization, and network latency, alongside application-specific metrics, a comprehensive understanding of the system's behavior is achieved. This data-driven, holistic approach minimizes the risk of misinterpretation and ensures that actions taken are based on verified root causes, thereby upholding the integrity of performance management and operational efficiency. An incorrect approach would be to immediately attribute the performance degradation solely to the application code without considering other contributing factors. This fails to meet professional standards by potentially leading to unnecessary and costly application code rewrites or tuning efforts, while the actual problem might lie in network congestion or insufficient server resources. Such a narrow focus can also lead to a failure to meet service level agreements, SLAs, if the underlying infrastructure issue is not addressed. Another incorrect approach would be to dismiss the metrics as unreliable without proper investigation. This demonstrates a lack of due diligence and can result in critical performance issues going unnoticed, potentially impacting business operations and customer satisfaction. Ethically, this represents a failure to provide accurate and timely information to stakeholders. Professionals should employ a decision-making process that prioritizes systematic data correlation. This involves 1. Initial observation and hypothesis generation based on the presented metrics. 2. Data gathering from all relevant sources, application, infrastructure, network. 3. Correlation and analysis to identify patterns and anomalies. 4. Hypothesis testing and validation. 5. Targeted remediation based on confirmed root cause. This structured approach ensures that decisions are informed, justifiable, and lead to effective problem resolution. Question 12. Process analysis reveals that the current data collection intervals within IBM SmartCloud Application Performance Management v7 are contributing to a slight delay in identifying critical application performance anomalies. To address this, which of the following actions would be the most professionally sound and aligned with best practices for process optimization within this environment? Option A. Rely solely on user feedback and anecdotal reports of slow anomaly detection to make broad, sweeping changes to APM data collection settings across all applications. Option B. Systematically review APM data collection configurations. Identify specific components or metrics where longer intervals are causing delays, and propose targeted adjustments to these intervals, followed by rigorous testing and validation of the impact on anomaly detection and system overhead. Option C. Disable data collection for less critical metrics to free up resources, assuming this will indirectly improve the speed of anomaly detection for more important metrics, without a detailed analysis of interdependencies. Option D. Immediately reduce the data collection interval for all monitored components across the entire APM deployment to ensure the fastest possible anomaly detection, without prior analysis of specific bottlenecks or potential performance impacts. The correct answer is B. Systematically review APM data collection configurations. Identify specific components or metrics where longer intervals are causing delays, and propose targeted adjustments to these intervals, followed by rigorous testing and validation of the impact on anomaly detection and system overhead. Explanation. This scenario presents a common challenge in IT operations, balancing the need for continuous improvement with the constraints of existing regulatory frameworks and operational stability. The professional challenge lies in identifying and implementing process optimizations within IBM SmartCloud Application Performance Management (APM) v7 without introducing risks that could lead to non-compliance or service degradation. Careful judgment is required to ensure that any changes align with the established operational procedures and any relevant IBM guidelines or best practices for APM deployment and management. The correct approach represents best professional practice because it prioritizes a structured, data-driven methodology for process optimization. By focusing on identifying bottlenecks and inefficiencies through APM data, and then proposing targeted, incremental changes, it minimizes disruption and risk. This aligns with the principles of responsible IT management, ensuring that improvements are validated and their impact is understood before full implementation. This methodical approach also supports auditability and compliance by providing clear documentation of the optimization process and its outcomes. An incorrect approach that involves making broad, unvalidated changes to APM configurations without a clear understanding of their downstream effects is professionally unacceptable. This could lead to unintended consequences, such as performance degradation, data loss, or security vulnerabilities, which could violate operational integrity and potentially IBM support agreements or internal governance policies. Another incorrect approach, such as relying solely on anecdotal evidence or user complaints without systematic data analysis, fails to provide a robust basis for optimization and risks, addressing symptoms rather than root causes, leading to wasted effort and continued inefficiencies. Implementing changes without proper testing and rollback plans introduces significant operational risk and demonstrates a lack of due diligence. The professional decision-making process for similar situations should involve a clear understanding of the current state of the APM environment, leveraging the diagnostic capabilities of APM itself to identify areas for improvement. This should be followed by a risk assessment of any proposed changes, a phased implementation plan with clear success criteria, and a robust monitoring strategy to validate the effectiveness of the optimizations and detect any adverse impacts. Documentation and communication throughout the process are crucial for transparency and accountability. Question 13. Stakeholder feedback indicates that a specific performance metric, as observed in their current SmartCloud application performance management V7 deployment, appears to be significantly lower than what they understood to be achievable based on marketing materials. They are requesting confirmation that this observed metric is indeed the best possible outcome for their application. Option A. Advise the stakeholder to immediately escalate this discrepancy to the IBM product development team for a potential bug fix. Option B. Politely inform the stakeholder that APM V7 marketing materials are aspirational and that actual performance is highly dependent on numerous external factors, without offering further investigation. Option C. Offer to conduct a targeted demonstration of the specific APM V7 functionality within their environment, using their application data to accurately assess the observed metric and discuss its context relative to APM's capabilities and potential optimizations. Option D. Immediately confirm that the observed metric represents the best possible outcome, as marketing materials often highlight peak performance scenarios. The correct answer is C. Offer to conduct a targeted demonstration of the specific APM V7 functionality within their environment, using their application data to accurately assess the observed metric and discuss its context relative to APM's capabilities and potential optimizations. Explanation. This scenario presents a professional challenge due to the inherent conflict between a stakeholder's immediate desire for a specific outcome and the ethical obligation to provide accurate and unbiased information. The core of the dilemma lies in balancing client relationships with professional integrity and adherence to IBM's best practices for SmartCloud application performance management, APM V7. The stakeholder's request, while seemingly straightforward, could lead to misinterpretations or misrepresentations of APM's capabilities, if not handled with careful consideration of the underlying data and its context. The correct approach represents best professional practice because it prioritizes transparency, accuracy, and a data-driven understanding of the APM solution. By offering to demonstrate the specific functionality requested within the context of the client's environment and data, the professional upholds the principles of responsible consulting and ensures that the stakeholder receives a realistic and actionable understanding of APM's value. This aligns with the ethical guidelines of providing truthful and complete information, avoiding overpromising, and focusing on delivering genuine solutions based on the product's actual performance and features as implemented. An incorrect approach that involves directly confirming the stakeholder's assumption without verification would be professionally unacceptable. This failure stems from a lack of due diligence and a potential misrepresentation of APM's capabilities. It bypasses the critical step of validating the observed behavior against the product's documented functionality and typical performance characteristics, potentially leading to unmet expectations and a loss of trust. Another incorrect approach, such as dismissing the stakeholder's observation without further investigation, is also professionally unsound. It demonstrates a lack of customer focus and an unwillingness to explore potential issues or unique environmental factors that might be influencing the observed behavior. This can alienate stakeholders and prevent the identification of genuine problems or opportunities for improvement within the APM deployment. A third incorrect approach, which involves immediately escalating the issue without attempting to understand the context or gather preliminary data, can be inefficient and may create unnecessary alarm. While escalation is sometimes necessary, it should be a considered step after initial assessment, not an automatic reaction. The professional decision-making process for similar situations should involve a structured approach. First, actively listen to and acknowledge the stakeholders' concern. Second, seek to understand the context and specific details of their observation. Third, propose a method for verification, such as a demonstration or data review, that is grounded in the actual APM v7 implementation. Fourth, if discrepancies are found, analyze the root cause, which could be configuration, environment, or a genuine product behavior. Finally, communicate findings transparently and propose appropriate next steps, whether that involves further configuration, training, or escalation. Question 14. Governance review demonstrates that the recent implementation of IBM SmartCloud Application Performance Management v7 has led to inconsistencies in key performance indicator reporting across different application tiers, raising concerns about data integrity and potential audit discrepancies. The project team is eager to showcase the immediate benefits of APM, but the inconsistencies suggest a potential misconfiguration or an unforeseen interaction with existing data collection agents. What is the most appropriate immediate course of action to address these concerns while ensuring the integrity of performance data? Option A. Immediately halt the full rollout of IBM SmartCloud APM v7 across all application tiers and initiate a detailed root cause analysis of the data inconsistencies, involving configuration review, agent compatibility checks, and validation against established data sources. Option B. Proceed with the full rollout of IBM SmartCloud APM v7 as planned, assuming the inconsistencies are minor and will be resolved through future patches or updates from the vendor. Option C. Disable the data collection modules within IBM SmartCloud APM v7 that are suspected of causing the inconsistencies, prioritizing the appearance of consistent reporting over detailed performance metrics. Option D. Instruct the application teams to manually reconcile the reported performance data from IBM SmartCloud APM v7 with their existing monitoring tools and spreadsheets until the inconsistencies are resolved. The correct answer is A. Immediately halt the full rollout of IBM SmartCloud APM v7 across all application tiers and initiate a detailed root cause analysis of the data inconsistencies, involving configuration review, agent compatibility checks, and validation against established data sources. Explanation. Scenario analysis. This scenario presents a common challenge in IT governance where the implementation of a new performance monitoring solution, IBM SmartCloud Application Performance Management, APM v7, has introduced unintended consequences impacting data integrity and compliance. The core challenge lies in balancing the immediate operational benefits of APM with the long-term implications for data accuracy, auditability, and adherence to internal policies and potentially external regulations. Though specific external regulations are not detailed for this exam, the principle of data integrity and compliance remains paramount. The pressure to demonstrate value from the new investment can lead to overlooking critical configuration details, creating a professional dilemma between speed of deployment and thoroughness. Correct approach analysis. The correct approach involves a systematic, phased rollout and validation process. This begins with a comprehensive understanding of APM's data collection mechanisms and potential impact on existing data sources. It necessitates rigorous testing in a controlled environment to identify and rectify any discrepancies or data corruption before widespread deployment. Establishing clear data validation procedures and involving relevant stakeholders, e.g., data stewards, compliance officers, application owners, ensures that the APM solution aligns with established data governance principles. This approach represents best professional practice because it prioritizes data integrity, minimizes risk of compliance breaches, and ensures the APM solution provides reliable insights, thereby maximizing its intended value. It aligns with the fundamental principles of IT governance that emphasize control, transparency, and accountability in system deployments. Incorrect approach is analysis. One incorrect approach involves proceeding with a full-scale deployment of APM without adequate pre-implementation testing or validation of its data collection and aggregation processes. This is professionally unacceptable because it risks widespread data corruption or misrepresentation, potentially leading to flawed business decisions, audit failures, and reputational damage. It violates the principle of due diligence in system implementation. Another incorrect approach is to disable critical data collection features within APM to avoid perceived conflicts, without a clear understanding of the long-term impact on performance visibility and troubleshooting capabilities. This is professionally unsound, as it undermines the very purpose of implementing APM and creates blind spots in performance monitoring, potentially leading to undetected issues and service degradation. It demonstrates a lack of strategic thinking and a failure to properly integrate the new solution. A third incorrect approach is to rely solely on vendor default configurations for APM without customization or validation against specific organizational data requirements and policies. This is professionally negligent as it assumes a one-size-fits-all solution, which is rarely the case in complex IT environments. It fails to account for unique data nuances, security requirements, or reporting needs, thereby compromising the effectiveness and compliance of the APM deployment. Professional reasoning. Professionals faced with this situation should adopt a structured decision-making process. First, thoroughly understand the capabilities and potential impacts of the IBM SmartCloud APM v7 solution, particularly concerning data handling. Second, conduct a risk assessment to identify potential data integrity and compliance issues. Third, develop a phased implementation plan that includes pilot testing, validation, and stakeholder engagement. Fourth, establish clear data governance policies and procedures for the APM deployment. Finally, continuously monitor and audit the APM solution's performance and data accuracy post-implementation to ensure ongoing compliance and effectiveness. This systematic approach ensures that technological advancements are implemented responsibly and ethically, safeguarding data integrity and organizational compliance. Question 15. Assessment of the potential impact of an IBM SmartCloud Application Performance Management v7 outage on an organization's critical business functions and regulatory compliance obligations requires a thorough understanding of which of the following. Option A. The historical performance metrics and trend data collected by APM v7 over the past year. Option B. The available capacity and scalability of the underlying cloud infrastructure hosting the APM v7 environment. Option C. The business criticality of the applications and services monitored by APM v7 alongside any relevant regulatory requirements for their availability and performance. Option D. The specific technical architecture of the APM v7 deployment and its integration points with other IT infrastructure components. The correct answer is D. The specific technical architecture of the APM v7 deployment and its integration points with other IT infrastructure components. Explanation. Scenario analysis. This scenario presents a professional challenge because it requires evaluating the potential consequences of a system outage on critical business operations and regulatory compliance. The challenge lies in accurately assessing the impact without over- or underestimating it, which could lead to misallocation of resources or failure to meet service-level agreements, SLAs, and regulatory mandates. The interconnectedness of applications within a cloud environment further complicates this, as a failure in one component can cascade and affect others, making a comprehensive impact assessment crucial. Correct approach analysis. The correct approach involves a systematic and data-driven assessment of the potential impact of an IBM SmartCloud Application Performance Management (APM) v7 outage. This includes identifying all critical applications and services monitored by APM, determining their business criticality, and quantifying the potential financial and operational losses associated with downtime. Furthermore, it necessitates understanding the regulatory implications, such as data integrity, availability requirements, and reporting obligations, that could be affected. This comprehensive approach ensures that mitigation strategies and recovery plans are prioritized based on actual risk and business needs, aligning with best practices for IT service management and risk management. It directly supports the principle of ensuring business continuity and compliance, which are fundamental to responsible IT operations. Incorrect approach is analysis, focusing solely on the technical aspects of the APM system without considering the business context is an incorrect approach. This would fail to recognize that the value of APM lies in its ability to support business operations, not just in its technical functionality. Such an approach could lead to underestimating the true impact of an outage, as it overlooks the downstream effects on revenue, customer satisfaction, and regulatory adherence. Another incorrect approach is to assume that any outage of APM v7 will have a catastrophic impact without performing a detailed analysis. This can lead to an overestimation of risk, resulting in excessive resource allocation to mitigation and recovery efforts that are not proportionate to the actual threat. This inefficient use of resources can detract from addressing more pressing issues and may not be justifiable from a business perspective. Finally, ignoring potential regulatory implications during the impact assessment is a significant professional and ethical failure. Many industries have strict regulations regarding application availability, data security, and performance monitoring. A failure to consider these can lead to non-compliance, fines, and reputational damage. This demonstrates a lack of due diligence and an incomplete understanding of the organization's operational environment. Professional reasoning. Professionals should adopt a structured impact assessment methodology that begins with identifying all affected components and services. This should be followed by an analysis of the business criticality of each, considering factors like revenue generation, customer impact, and operational dependencies. Subsequently, the potential financial, operational, and reputational consequences of an outage must be quantified. Crucially, the assessment must incorporate an evaluation of regulatory and compliance requirements that could be jeopardized. This holistic approach allows for informed decision-making regarding resource allocation, risk mitigation, and the development of robust business continuity and disaster recovery plans, ensuring alignment with organizational objectives and regulatory obligations. Question 16. Comparative studies suggest that implementing IBM SmartCloud Application Performance Management v7 across a hybrid cloud environment presents unique integration and performance challenges. A common pitfall is the failure to adequately prepare the target infrastructure and applications for agent deployment. Considering the need for comprehensive monitoring without compromising existing system stability or security, which of the following implementation strategies best mitigates these risks and ensures a successful deployment? Option A. Prioritizing the deployment of APM agents on the most critical production systems first, without extensive pre-deployment testing in a controlled environment. Option B. A big bang deployment across all target systems simultaneously to achieve immediate comprehensive coverage. Option C. Deploying APM agents with default configurations across all environments without prior assessment of specific security or performance requirements. Option D. A phased deployment approach, starting with a pilot in a non-production environment, followed by a gradual rollout to production systems after thorough validation and performance testing. The correct answer is D. A phased deployment approach, starting with a pilot in a non-production environment, followed by a gradual rollout to production systems after thorough validation and performance testing. Explanation. Scenario analysis. This scenario presents a common implementation challenge where a critical performance monitoring tool, IBM SmartCloud Application Performance Management, APM v7, needs to be deployed across a hybrid cloud environment. The challenge lies in ensuring consistent and effective monitoring without introducing performance degradation or security vulnerabilities, especially when dealing with sensitive application data. The complexity arises from integrating APM with diverse on-premises and cloud-based infrastructure components, each with its own configuration and security protocols. Professionals must balance the need for comprehensive visibility with the imperative to maintain system stability and compliance. Correct approach analysis. The correct approach involves a phased, risk-based deployment strategy. This begins with a thorough assessment of the target environment, identifying potential integration points, dependencies, and security considerations. A pilot deployment in a non-production or less critical environment is crucial to validate the APM configuration agent deployment, and data collection mechanisms. This allows for early detection and remediation of issues, minimizing disruption to production systems. The strategy should also incorporate robust testing of APM's impact on application performance and resource utilization. Adherence to IBM's best practices for APM v7 deployment and configuration, as outlined in its official documentation and support resources, is paramount. This approach ensures that the implementation is technically sound, operationally stable, and aligns with the organization's overall IT governance and security policies, thereby upholding professional responsibility in system management. Incorrect approach is analysis. A big bang deployment without prior testing or a phased approach is professionally unacceptable. This strategy significantly increases the risk of widespread system instability, performance degradation, and potential data loss. It demonstrates a failure to adequately assess and mitigate risks, which is a core tenet of responsible IT implementation. Deploying APM agents without considering the specific security configurations of each environment, e.g., firewall rules, access controls, poses a significant security risk. This could lead to unauthorized access to sensitive application data or compromise the integrity of the monitoring system itself, violating professional ethical obligations to protect data and systems. Implementing APM without a clear understanding of its resource requirements on the target systems can lead to performance bottlenecks. This oversight can negatively impact the very applications APM is intended to monitor, demonstrating a lack of due diligence and technical foresight. Professional reasoning. Professionals should approach APM implementation by first understanding the business objectives for performance monitoring. This is followed by a detailed technical assessment of the hybrid environment. A risk assessment matrix should be developed, identifying potential technical, operational, and security risks. Based on this, a phased deployment plan, including pilot testing and rollback procedures, should be created. Continuous monitoring of APM's own performance and its impact on the monitored applications is essential throughout the deployment and operational phases. Collaboration with application owners and infrastructure teams is critical to ensure alignment and address any concerns proactively. Question 17. The audit findings indicate a significant degradation in application performance, with IBM SmartCloud Application Performance Management v7 data showing increased response times and error rates during peak hours. A senior manager, concerned about customer impact and potential SLA breaches, has requested an immediate explanation and a clear assignment of responsibility. What is the most appropriate initial course of action? Option A. Initiate a detailed, objective investigation using IBM SmartCloud APM v7 diagnostic tools to identify the root cause of the performance issues, involving relevant technical teams without premature blame assignment. Option B. Advise the senior manager that the performance issues are likely transient and recommend monitoring the situation without immediate intervention, as further data might be needed. Option C. Suggest to the senior manager that the APM data might be inaccurate or misconfigured, and propose a system reset to clear potential anomalies before further analysis. Option D. Immediately inform the senior manager that the development team is responsible, citing the error rate increases shown in the APM data as primary evidence. Correct answer is A. Initiate a detailed, objective investigation using IBM SmartCloud APM v7 diagnostic tools to identify the root cause of the performance issues, involving relevant technical teams without premature blame assignment. Explanation. This scenario presents a common ethical dilemma in IT environments where performance data might be misinterpreted or selectively presented. The challenge lies in balancing the need for accurate reporting with the potential for negative consequences for individuals or teams, and ensuring that the use of IBM SmartCloud Application Performance Management (APM) v7 aligns with ethical data handling and reporting practices. The correct approach involves a thorough, objective investigation of the audit findings, focusing on the root cause of the performance anomalies rather than assigning blame prematurely. This aligns with best professional practice by prioritizing data integrity, transparency, and a problem-solving mindset. It upholds the ethical principle of fairness by seeking to understand the situation comprehensively before drawing conclusions or taking action. In the context of IBM SmartCloud APM v7, This means utilizing the tool's diagnostic capabilities to pinpoint the exact issues, whether they are code-related, infrastructure-related, or configuration-related, and documenting these findings objectively. An incorrect approach would be to immediately attribute the performance degradation to the development team without further investigation. This is ethically problematic as it bypasses due diligence and could lead to unfair accusations and disciplinary actions. It fails to uphold the principle of fairness and could damage team morale and trust. From a regulatory or guideline perspective, such an action could be seen as a failure to follow proper incident management and root cause analysis procedures, potentially violating internal IT governance policies that mandate objective investigation. Another incorrect approach would be to ignore the audit findings, hoping the issues resolve themselves or are not significant enough to warrant attention. This is professionally irresponsible and ethically unsound. It demonstrates a lack of accountability and a disregard for service quality and user experience. From a compliance standpoint, ignoring audit findings can lead to breaches of service-level agreements, SLAs, and a failure to meet operational objectives, which could have regulatory implications depending on the industry and specific service being monitored. A third incorrect approach would be to manipulate the APM data to obscure the severity of the performance issues or to shift blame. This is a severe ethical violation, constituting data falsification and dishonesty. It undermines the integrity of the monitoring system and any subsequent reporting, leading to potentially disastrous business decisions based on inaccurate information. This action directly contravenes principles of data integrity and professional conduct and could have severe legal and reputational consequences. The professional decision-making process for similar situations should involve 1. Acknowledging the audit findings and initiating a formal investigation. 2. Utilizing the full capabilities of IBM SmartCloud APM v7 to gather objective, detailed performance data. 3. Conducting a thorough root cause analysis involving relevant stakeholders. 4. Documenting all findings factually and impartially. 5. Communicating findings and proposed solutions transparently. 6. Focusing on remediation and continuous improvement rather than punitive measures, unless gross negligence is proven. Question 18. To address the challenge of a critical performance anomaly detected by IBM SmartCloud Application Performance Management v7 that is impacting user experience and potentially data integrity, what is the most prudent course of action to ensure both immediate system stability and long-term compliance and auditability? Option A. Proceed with a rollback of the application components, but ensure all diagnostic data collected by APM leading up to the anomaly is immediately purged to reduce storage overhead. Option B. Conduct a thorough root cause analysis of the anomaly, involving key stakeholders and assessing the impact of any potential rollback on audit logs and compliance requirements before making a decision. Option C. Temporarily disable monitoring for the affected components to prevent further alerts while a full system upgrade is scheduled, deferring any immediate resolution. Option D. Immediately initiate a rollback of the affected application components to the last known stable configuration, prioritizing the restoration of service without further investigation. Correct answer is D. Immediately initiate a rollback of the affected application components to the last known stable configuration, prioritizing the restoration of service without further investigation. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for system stability with the long-term implications of data integrity and compliance. The decision maker must consider the potential impact of a hasty rollback on ongoing investigations, audit trails, and the overall trust in the application performance management system. The core of the challenge lies in the potential for a rollback to obscure or destroy evidence, which could have significant regulatory and operational consequences. The correct approach represents best professional practice because it prioritizes a thorough, data-driven decision-making process that aligns with established IT governance and compliance principles. By involving key stakeholders, documenting the rationale, and assessing the impact on compliance and auditability, the team ensures that any action taken is informed, defensible, and minimizes risk. This aligns with the general principles of responsible IT management, which emphasize transparency, accountability, and adherence to regulatory requirements for data handling and system integrity. While the specific jurisdiction for C2010 C2010-515 IBM SmartCloud Application Performance Management V7. 7 Fundamentals is not explicitly stated as a particular country's regulatory framework. The principles of good IT governance and data integrity are universally recognized and often underpin regulatory expectations in areas like data protection and financial reporting. An incorrect approach that immediately initiates a rollback without proper assessment fails to consider the potential loss of critical diagnostic data. This could violate internal policies regarding incident response and data retention, and more importantly, could hinder any subsequent forensic analysis or compliance audits. If the application performance data is subject to regulatory oversight, e.g., for financial reporting accuracy or security incident logging, its destruction or alteration through an unmanaged rollback could lead to non-compliance penalties. Another incorrect approach, focusing solely on restoring the previous state without considering the root cause or the impact on ongoing monitoring, neglects the fundamental purpose of an APM system. This approach risks repeating the problem or failing to address underlying issues, potentially leading to further instability and a loss of confidence in the system's ability to provide accurate performance insights. Ethically, this demonstrates a lack of diligence in maintaining the integrity and effectiveness of a critical IT service. A third incorrect approach, delaying any action indefinitely due to fear of making a mistake, is also professionally unacceptable. This inaction can lead to prolonged system instability, impacting business operations, and potentially causing greater damage than a carefully considered rollback. It also fails to uphold the professional responsibility to manage and resolve IT incidents in a timely and effective manner. The professional reasoning framework to employ in such situations involves a structured incident management process. This typically includes 1. Incident identification and logging, 2. Incident assessment and prioritization, 3. Diagnosis and investigation, 4. Resolution and recovery, and 5. Post-incident review. Crucially, at each stage, the potential impact on data integrity, audit trails, and regulatory compliance must be explicitly considered. Documentation of all decisions and actions is paramount for accountability and future reference. Question 19. Process analysis reveals that users are experiencing intermittent delays when accessing critical application functions managed by IBM SmartCloud Application Performance Management V7. 7. The performance team suspects a bottleneck within the application's transaction processing, but is unsure of the exact component causing the slowdown. Which of the following strategies is the most effective for diagnosing and resolving this performance issue? Option A. Temporarily disable certain monitoring agents within IBM APM v7. 7. To reduce system overhead, hoping this will improve overall application responsiveness. Option B. Utilize IBM APM v7. 7. To trace individual transaction flows, analyze resource utilization metrics for each component involved in the transaction, and identify specific code paths or database queries exhibiting high latency or error rates. Option C. Focus exclusively on optimizing the user interface and front-end loading times, as user-perceived slowness is often attributed to these elements. Option D. Immediately provision additional server resources across all application tiers, assuming a general capacity issue is the cause of the delays. The correct answer is B. Utilize IBM APM v7. 7. To trace individual transaction flows, analyze resource utilization metrics for each component involved in the transaction, and identify specific code paths or database queries exhibiting high latency or error rates. Explanation. This scenario presents a common challenge in performance management, identifying and addressing bottlenecks that impact application responsiveness and user experience. The professional challenge lies in accurately diagnosing the root cause of performance degradation within a complex distributed system like IBM SmartCloud Application Performance Management, APM, v7, and then implementing effective optimization strategies without introducing new issues or violating operational best practices. The need for careful judgment arises from the potential for misdiagnosis, leading to wasted resources, further performance problems, or even service disruptions. The correct approach involves a systematic and data-driven methodology for process optimization. This means leveraging the diagnostic capabilities of IBM APM v7. 7. To gather detailed metrics on transaction flows, resource utilization, and error rates across different application tiers. By correlating these metrics, performance analysts can pinpoint specific components or interactions that are contributing most significantly to the observed latency. Implementing targeted optimizations, such as code refactoring, database query tuning, or infrastructure adjustments based on this empirical evidence, represents best professional practice. This aligns with the principles of efficient system operation and service delivery, ensuring that improvements are directly addressing identified issues and are measurable. An incorrect approach would be to implement broad, unverified changes without a clear understanding of their impact. For instance, randomly increasing server resources without identifying a specific resource constraint is inefficient and may not resolve the underlying problem. This approach lacks the data-driven rigor expected in performance management and could lead to unnecessary costs. Another incorrect approach is to focus solely on front-end user interface improvements when the bottleneck lies in the back-end processing or database interactions. This misdirected effort fails to address the true source of the performance issue and can lead to user frustration if the core problem remains unresolved. A third incorrect approach might be to disable certain monitoring features of APM v7 to speed things up. This is fundamentally flawed as it removes the very tools needed to diagnose and understand performance, creating a blind spot and potentially masking critical issues. Such actions would be considered professionally negligent as they undermine the integrity of the monitoring system and the ability to maintain optimal performance. The professional reasoning process for similar situations should involve 1. Clearly defining the observed performance problem. 2. Utilizing APM v7 to collect comprehensive diagnostic data. 3. Analyzing the data to identify root causes and contributing factors. 4. Prioritizing optimization efforts based on impact and feasibility. 5. Implementing targeted changes. And 6. Continuously monitoring the system to validate the effectiveness of the changes and identify any new issues. This iterative, data-informed approach ensures that performance optimization is a controlled and effective process. Question 20. The efficiency study reveals that IBM SmartCloud Application Performance Management v7 is collecting detailed transaction data that could indirectly reveal sensitive customer information. To ensure regulatory compliance, what is the most appropriate action to take regarding this data? Option A. Continue collecting all raw transaction data as is, assuming that performance analysis is the sole purpose and no direct personal information is being logged. Option B. Rely solely on end-user consent forms to permit the collection of all transaction data without further technical or administrative safeguards. Option C. Disable the monitoring of application components that are suspected of handling sensitive customer information to eliminate any potential data exposure. Option D. Implement data anonymization techniques for sensitive fields within the collected transaction data and enforce role-based access controls for APM v7 users. The correct answer is D. Implement data anonymization techniques for sensitive fields within the collected transaction data and enforce role-based access controls for APM v7 users. Explanation. The efficiency study reveals a potential gap in how IBM SmartCloud Application Performance Management (APM) v7 data is being handled concerning regulatory compliance. The challenge lies in balancing the need for performance monitoring and data analysis with the stringent requirements for data privacy and security mandated by relevant regulations. Professionals must ensure that the collection, storage, and access of APM data adhere to these legal and ethical obligations, particularly when sensitive information might be indirectly captured or inferred. The correct approach involves implementing robust data anonymization and access control mechanisms within the APM v7 environment. This aligns with the principle of data minimization and purpose limitation, ensuring that only necessary data is retained and accessed by authorized personnel for legitimate performance analysis purposes. By anonymizing sensitive identifiers, organizations can significantly reduce the risk of privacy breaches and comply with regulations that require protection of personal or confidential information. This proactive stance demonstrates a commitment to regulatory adherence and ethical data stewardship. An incorrect approach that involves retaining raw, unanonymized performance data without strict access controls poses significant regulatory and ethical risks. This failure directly contravenes data protection principles, potentially exposing sensitive information and leading to non-compliance with regulations. Another incorrect approach, such as disabling data collection for sensitive application components altogether, might seem like a risk mitigation strategy, but can hinder effective performance monitoring and troubleshooting, ultimately impacting service delivery and potentially violating service-level agreements or other operational mandates. A third incorrect approach, relying solely on end-user consent for data collection without considering the broader regulatory landscape and the potential for inferred sensitive data, is insufficient. Consent alone does not absolve an organization of its responsibility to implement appropriate technical and organizational measures to protect data. Professionals should adopt a decision-making framework that prioritizes understanding the specific regulatory requirements applicable to their operating jurisdiction and the type of data being processed by APM v7. This involves conducting a thorough data privacy impact assessment, identifying potential risks, and implementing a layered security and compliance strategy. This strategy should include technical controls like anonymization and encryption, administrative controls like access policies and training, and ongoing monitoring to ensure continuous compliance.